Now let's say replica sets in action. The first thing that we want to do is we will create a manifest file to deploy a replica set. And the replica set should run 5 pods at the same time. So all of them would be the same pods. And it will select the pods which has label key as env and label value as ktest training. So we'll create a replica set manifest file which will launch 5 pods as part of the replica set. And this should be the manifest file for the replica set. Notice that all the 4 top level keys are same: API version, kind, metadata, and spec. The first apparent change is the API version. Here the API version is apps/v1. The next change is kind, wherein the kind is replica set. Then in metadata, I'm naming this replica set to be ktest replica set. This is the name of the replica set, and this is the label of the replica set, not the pods. Then you have specifications or spec. The replica should be 5. And then I'm mentioning selectors. And in selectors, I'm using match labels, not match expressions. If I wanted, I could have used match expressions also. And the requirement is that I want to select all the pods whose label key is env and its value is ktest training. And after that, we have the template. In template, we are mentioning the pod manifest file minus the API version and kind. So in template, this is the metadata of the pod. The name of the pod would be ktest rs demo. Label of the pod is env ktest training. You have to mention this because this is the pod which is being selected here. In the specification of the pod, we are mentioning containers. It has only one container, Python web page, from image this one, and then we are passing environment variable to this container. Let us go ahead and create it. Okay, replica set has been created. The way you get information of the replica set is kubectl get rs. We have 2 replica sets are running. I'll delete the second replica set. Alright, we have one replica set, ktest replica set. Now let us go ahead and try to dig a little deeper into this replica set. We want to know which pods have been launched as part of this replica set and what are the other things that this replica set has done. To get that information, we run the describe command with the replica set. Sorry, it should have been replica set describe rs, and then you see all these information. The first information is the name of the replica set. Then we have something called namespace, which I have not discussed yet. And then the selector is the selector for the pods of this replica set. That means using this expression, all the pods have been selected. Then we have labels. This label is nothing but the label of the replica set, not the pods. We have not discussed annotations yet. Then what is the current and desired state? The current state is that 3 pods are running. Then it talks about the pod template also. Pod template has a label of env ktest training, and these are the containers, Python web page with an image. We have not mentioned any container port or host port yet, passing some environment variables, no mounts and volumes. And then finally we go to events, and this is where you find the pods that have been created as part of this replica set. These are the 3 pods which have been created. Now let us go ahead and see the pods. And there you go. These are the 3 pods, and each pod is running one container as part of this replica set. Let us go ahead and describe one of the pods. And this is the information. The name of the pod is this one. Namespace is default. It is running on worker 2 node. It has a label of env ktest training, no annotations. Notice this one, controlled by. So this pod is being controlled by replica set, and the name of the replica set is ktest replica set. And rest of the things are same. We have Python web page container, which is getting the image from here. And in the events, it says the containers have been created successfully inside of the pod. Rest of the things are pretty same, but the only change is the controlled by. And this pod is controlled by a replica set with the name ktest replica set. And you'll find the same information for the other pods also. Now the next thing I want to show you is scale out and scale in. Let's say I want to increase the number of pods to 7 rather than 5. Actually, let's do it 5 because we have launched only 3 pods as part of the replica set. We'll change it to 5 now. So we'll scale out and also we'll scale in. That means after some time, we'll reduce the number of pods as well. And to scale the replica sets, this is the command you run: kubectl scale, mention the number of replicas, and then the replica set. Sorry, I should have mentioned dash dash replicas. Now, if you notice, we have 5 pods running. You can describe the replica set again to find out that the additional pods which have been launched because of the scale out. And it says that it created 2 new pods at the bottom, if you see, and these creation were latest, and 2 new pods have been added. So let us scale in as well. To scale in, you just mention the number of replicas less than the current one. So number of replicas would be 2. So this replica set has been scaled. Let us go ahead and see the number of pods. It is running 3 pods. One of them is being terminated. And after this, after a few time, we'll see that only 2 pods are running as part of this replica set. Let us describe the replica set again to find out a little bit more detail. Now, at the end of the event, if a few things have been appended, these 3 pods are being deleted because we did a scale in and reduce the number of pods. The next thing I want to show you is self-healing. That means, let's say you have 3 pods running and you delete one of the pods. What Kubernetes or the replica set will do? It should start that pod automatically. So if you have 5 pods running and you delete one of them, it should start that pod automatically again, because as I said, it runs something called a watch loop. It will always match the current state with the desired state, and if the current state and the desired state do not match, it will go ahead and try to match them. So the moment we delete a pod, the desired state would say 5 pods should be running, but as part of the current state, it will show only 4 of them are running. So it will start one more. So this is how self-healing of pod happens in Kubernetes. Let us go ahead and see that. And this is the replica set. We have 5 pods running as part of the replica set. So currently desired state and current state matches. Let me go ahead and delete a pod manually. Even after I deleted the pod, if I see again, one more pod has been started and the other pod is not same as the previous one which I had deleted. So this is what self-healing does. So let us describe the replica set to find a little bit more detail. So it says that the replica set controller has created this pod. It is not showing that the pod has been deleted because it was a manual delete of the pod. Replica set did not delete it. We did it ourselves. So that's why the delete command or the pod delete event has not been captured as part of the replica set. But as the replica set controller added or created a new pod, which is this one, that's why it is showing it here. So now if we delete, let's say 2 pods, we should be able to see after some time that the replica set has created 2 more pods. Again, 5 pods are running even though we deleted the 2 pods. So this is the self-healing characteristic of replica set, and this is what enforcement of desired state in Kubernetes. So the watch loop keeps on watching the desired state and the current state. Desired state says that it should run 5 pods, but after I deleted the 2 pods, the current state went down from 5 to 3. So to match the desired state, the controller has to spin up 2 more pods, and that's what it did. So after running 2 more pods, the desired state and current state matched again. So the watch loop stopped. So this is how self-healing happens now using replica set. Now the same thing is not possible if you do it by yourself, if you do not use replica set. Now the one more piece which you want to do is we'll create a separate pod with label env test training, and let's see what happens. And the reason it is interesting because it will have a different container altogether, and you'll see that this pod will be engulfed in the replica set. But there's a problem because the desired state of the replica set is 5, and currently the replica set is running 5 pods. So what will happen? Let us go ahead and see. All right, this is the pod, and the name of the pod is pod hyphen non-templated pod, and the container is completely different. It is the name of the container is HTTP web page, and the image is also different. But what we want to do is we want to change the label to env ktest training and launch this pod. So let us go ahead and create the pod. All right, the pod has been created. We cannot see the pod. What happened? So as I said, creating pods separately has some dangerous implications. So the pod was created because you could see this message that pod hyphen non-templated pod created. But as it has a label of env ktest training, it was taken by the replica set because the labels are matching with the replica set selector. Now, once it was taken by the replica set, the desired state and current state did not match because the desired state was 5 and the current state became 6 because 5 pods are already running as part of this replica set. So once this pod was taken by the replica set, the current state changed from 5 to 6. So the while loop came into action again. It had to run only 5 pods, so the 6th pod was deleted. Now, as it was deleted by the replica set, it should show or it should come up in the event section of the output of describe replica set. So let us see. There you go. Now the pod was created by us separately than the replica set, but as it had a label of env ktest training, it was taken by the replica set and it was deleted because the replica set did not need another pod. It was already running 5 pods. So this is one of the very dangerous implications of creating pods separately than that of the replica sets, which is called non-templated pod, which is our next demo. To delete a replica set, you type kubectl delete rs and the name of the replica set. And what it will do is it will go ahead and delete all the pods along with the replica set. We will not find any rs and will not find any pods. So all the pods would be deleted the moment we delete the replica set.